Welcome to all of you tuning in. We're about ready to start the last session of the day, featuring our guests from the Frederick National Laboratory for Cancer Research. A couple of reminders: we will be sending an email with links to the presentations in the next day or so keep an eye out for that. And we are taking questions at the end of the session, so please don't hesitate to ask a question or two using the questions tab located at the top of your screen. If we don't get to your question, you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. And lastly, be sure to post about today's connection using hashtag Neo4j or hashtag Neo4j Connections to be entered to win some cool Neo4j swag. And without further delay, I'll hand the floor over to Lance Walter, Chief Marketing Officer at Neo4j, to introduce today's final session.
Excellent. Thank you, Marilee. We always like to finish connections strong, and today's event is no exception. I'm super excited to have the opportunity to welcome the team from Frederick National Laboratory for Cancer Research. Mark Jensen is the organization's Director of Data Management and Interoperability, and Mark is joined by Todd Pihl, Director and Technical Project Manager, as well as Ming, Ying, Senior Software Engineer. We're bringing together a lot of expertise in disease research, data management, analytics, and graphs, and I know you're going to enjoy the session. So I'm going to go ahead and get out of the way, and thank you for attending today's Connections. Welcome, Mark, Todd, and Ming to Neo4j Connections.
Thank you, Lance, for the kind introduction. So I'm Todd Pihl from the Frederick National Lab for Cancer Research. We're associated with the National Cancer Institute. And today, along with my colleagues Ming, Ying, and Mark Jensen, we're going to talk about something we call the Bento framework, which is part of NCI's cancer research data ecosystem. So we're going to go through a few of the things today about Bento, such as why was it built, what is it? We'll get into the technical details about that, about how it works, and how Neo4j fits in. And then we'll finish up with where Bento goes next. But to really understand why we're building Bento, it helps to understand what NCI is attempting to accomplish. So as part of the Cancer Moonshot, NCI is building what they call the Cancer Research Data Commons. And this is a series of data repositories, tools, and user workspaces that allow users to access data from NCI projects, such as the Cancer Genome Atlas. So on the data repository end, we have such things as the Genomic Data Commons that stores genomic data and mutational data, or the Imaging Data Commons that stores radiology or pathology images, as well as a variety of other data repositories. Now, each one of these will allow users to come in, search, and build cohorts of patients that they find interesting. They then take those data to what we call the cloud resources. These are user workspaces that come pre-populated with analytical tools and help, and allow users to bring in their own laboratory data and combine with what NCI is providing and perform a wide variety of analyses in the cloud. A tool that will be coming soon is something called Cancer Data Aggregator. So rather than having to go data repository by data repository with your search, you'll be able to launch a single search through Cancer Data Aggregator. And this is powered through a semantic data model that has been created by the Center for Cancer Data Harmonization. And we expect that this will be a much easier way of finding and utilizing the data that you need. So with this ecosystem in mind, the NCI asked us to build two of these data commons, or data repositories. The first, the Integrated Canine Data Commons, is designed to hold data from canine clinical trials. Unfortunately, dogs, like humans, come down with cancer, and there are a variety of both therapeutic and treatment clinical trials that are performed, and data from these wind up in the Integrated Canine Data Commons. And then there's the Clinical Trials Data Commons, which is similar but focuses on human clinical trials. Now, when we went into this, we realized that these two data sets, or these two data commons, would have a great deal in common. Users would come in, they would want to be able to search on data sets that they're allowed to see. They would want to be able to take those to one of the cancer cloud resources and do analyses. So rather than build them as independent entities, we decided to build a framework that we now call Bento. And this, at its core, really serves as a foundry for how you can stand up quickly, very easily and very quickly, stand up new data commons. So each of these, Bento is designed to be very modular, and each of these modules can be customized fairly readily without a lot of programming involved, or in some cases with no programming involved. And so because of this, we can see that Bento can save an enormous amount of time and therefore money in standing up a new data commons. The first one of these was the integrated canine data commons, and that took us about 9 months to build. But then when we worked on the clinical trial data commons, we were able to leverage that framework, and we cut that down to 4 months. Now with these two under our belts and additional development, we can stand up a Bento-based data commons in somewhere from 2 to 4 weeks, depending upon the degree of customization that has to be done. So to get into the real technical details of this, I'm going to pass this to my colleague, Mark Jensen, who's going to start explaining how Bento works at a fundamental level.
Thanks a lot, Todd. Bento is architected such that not only does it use sort of modern, very modular architecture, as you can see here, microservices. Each of the main components of Bento is contained in a virtual machine, a virtual container. But we also wanted to make sure that it was cloud capable and that it would be able to take advantage of some of the latest, most flexible NoSQL databases that we could use. And of course, one of those is Neo4j. One of the key features of Neo4j from the engineering standpoint is that it's performant enough to drive not only the persistence layer, that is the underlying sort of database of record, but it can also drive the user interface and handle the queries that are coming from that in order to interactively display the results of queries that the users want to make. And that, I think, adds a key, is a key discriminator of Bento. There isn't a lot of creating of materialized views that are fast so that they can be displayed on the UI. Bento can power that, especially if you have a relatively small set of data. So all this comes down, well, let me go through the stack, the technology stack. It's apart from Neo4j, which is new and cool, we have our old standbys of Java and Python. GraphQL is really important for our APIs, and it is able to encapsulate a lot of the detailed queries that we need to do on the Neo4j end, so that the UI developers who are mainly using React.js can go right in and get what they need without having to become Neo4j or Cypher experts. All this leads to a loose coupling of components from UI all the way down to the back end that we find very efficient both in our development and in the actual use and setup of Bento, which we'll talk a little bit about right now. So we have this persona that we imagine called the custodian. And the custodian is not an engineer, but a subject matter expert, maybe a business analyst or somebody who really knows the data that you're trying to load into Bento. And one of our principles of design for Bento was to make it possible for a subject matter expert to stand up the Bento machinery and to be able to operate on the data at the level of the data rather than the level of the database in some sense. So we try to make it easier for the custodian, the subject matter expert, to do all these things. They can pull down the code base from GitHub. It's open source and free. They can configure rather than code Bento, and they can do it locally on their machine, right on their desktop. They can deploy it anywhere, including into the cloud. We can support 2 cloud providers. One is AWS, that's our main one, Amazon Web Services, but we also are working to support Google Cloud platform as well. And then really important to us as people, as a group that wants to serve the users, providing really detailed documentation and documentation that gets updated as the platform gets updated. So to discuss Bento and its configuration, you can think in terms of different degrees depending on the level of customization that you want. So if you want to run Bento out of the box, it's ready to do that. It has a UI that's attractive and functional. It's got the core API, which is based on that GraphQL, and that plugs right into the Neo4j underlying database. Say you have different data that you want to add, or you have a different model in mind. It's easy to configure the data model. I'll show you a little bit about that in the next couple of slides. And once you configure that model, the API sort of automatically conforms to that configuration, and the UI is able to handle it right out of the box. Finally, if you need custom graphic design elements and other widgets, as it were, you can also configure those at sort of a third level of configuration, where you can extend the data model. You can provide custom queries that give you back what you need in a custom way for certain displays. And you can build out that user interface to include your own graphic user elements. So how do we do this configuration of the data model? Something we developed that was really, again, subject matter expert, business analyst focused is what we call the model description format. It's compact, it's human readable, it's in YAML format, but it's computable, and it enables a subject matter expert to define a property graph, define a graph consisting of nodes, relationships, and properties. It lays them out in an easy to read way. It sort of attempts to hide background details and allow you to split apart different aspects of your model into different files. So things that don't change very often can stay in a file, but things that may get added to frequently have their own file. It's very flexible. It's not the only way or even the only thing out there that could be used to do this, but we were really after something that was very subject matter expert focused and simple. Here's how it looks. I won't go over these in detail, but the MDF can be split up into multiple files. As I say, generally one file will contain the nodes, and they're simply listed under a nodes section, relationships as well. You can specify which nodes are the source and the destination for each of the relationships that you make. You also specify other important details, such as the cardinality of those relationships. In another file, generally we keep the property definitions. You instance those properties, instantiate those properties in the nodes or the edges areas, but then you can define the acceptable values or the data types, for example, of those property definitions elsewhere. And that's basically, it's laid out in this way. I'll just quickly show you, and if you go back over the video, you can see these in more detail. Again, trying to provide an intuitive way to configure Bento's data model without getting into too much engineering or coding. Another area in which we make use of Neo4j separately from the back end of Bento is in a thing we call the metamodel database. So as Todd was suggesting, we have a number of different CRDC repositories that we're building, and each one has its own model. So given that, we'd like a single place where we could keep these models along with their structure, their node property relationship structure, and perhaps link them together, link elements of these models that are the same but may be called by different terms, store those acceptable value sets that, for example, a property might be diagnosis, and there might be 1,000 terms in a standard list of diagnoses, but they still have to be stored someplace and kept up to date. So we developed this meta model database that allows us to store our models in another large Neo4j graph. It works pretty well, and we're happy to talk more about it. If you go to the link on the bottom, you can see its description as well as a number of codes that you can play with and look at. Finally, in my section, I just want to give you a testimonial. This is from our product owner, the main business analyst and data SME for the Canine Data Commons. Phil wrote this to me on Slack just the other day, and the main thing that I want you to see is that Phil is able to get model changes done himself. And one of the main reasons to use Neo4j is to be able to be flexible, because these projects that we work on, their data changes, new data is added, and we have to be able to respond to that and not always take the engineering team and put them to work on these smaller changes. They need to be working on the larger overall roadmap. So Phil is able to do these things, and that is just proving to us that the Bento mode of working seems to be doing what we hoped it would do. So now I'd like to hand it over to Ming Ying. He's a senior engineer, and he does most of the Neo4j engineering for us. Ming?
Thanks, Mark. So let's dig a little deep into our system. First, we're going to take a look at our data pipeline. So our data comes in TSV files, tab separated values. So in these files, especially this one, you can see each row represents a case node. Column 2 and column 3 specify relationship to the parent nodes. In this case, the first parent is a study node identified by the property called clinical study designation. The second parent is a cohort identified by property cohort description. And the data loader read the files in and also read the data model in to validate the data, then generate several queries to load the data into Neo4j. So once loaded, we have nodes, properties in there, and also relationships between the nodes. So next is our backend architecture. So our backend provides a GraphQL API, and the GraphQL functionality is mainly provided by the Neo4j GraphQL plugin, which is installed in Neo4j itself. We wrote a Java application which is used to block unwanted mutations, and also if there's a requirement for authentication and authorization, that will be in the Java application. We also have a Redis as a cache to improve the performance. So first, if a client sends the GraphQL to the Java application, the Java application gonna send that to Redis first to see if there's any result already in there. Then if we got a null back, we know this is a new one. So we're gonna send that, forward that GraphQL query to Neo4j GraphQL plugin. Then we get a result back from the plugin. We put it in our Redis cache as a key value pair. Then we return the data to our client. Now imagine if some client, could be the same or a new client, send the same query to our Java application. Then we send the GraphQL to Redis to see if we already have some data for that. In this case, we have, so we got the data from Redis and then return directly to our client. So the core core element here is the Neo4j plugin, Neo4j GraphQL plugin. So why we use that? Several reasons. First one is very easy to set up. On our local, we use Neo4j desktop. There's a button to install that plugin directly in there. When it's on server, just a jar file drop into a folder and a couple lines of configuration, then you are done. And it's very easy to use. It only requires one file, one schema file to power the whole API. So the whole API is just one file. We can swap the file and get a new API for different data comments. So there are a lot of easy to use features, such as automatic generated queries based on our schema file. Also, if you have some complicated queries, then you can write them in the schema file with Cypher, which I will show a little later. And the customer support is awesome. We used the customer support a couple of times to request some version update. We always get a response in a couple of hours and issue result in a couple of days. That's always a plus. So all the queries of our application are written in this one schema file, GraphQL schema file. So when the Java application starts up, it loads the schema file into Neo4j plugin, which will handle the GraphQL processing and the data fetching based on our schema file. On the left, you can see those are type definitions. You give name, what properties you have, and the type of the properties. On the right is a custom query. You define the name, some parameters. You can also give default values for those, so those can be optional. And also you define the return type. And the most important part is the Cypher annotation here. We put a whole complicated Cypher query in here to power this query. So when we develop these queries, we use Neo4j desktop on our laptop. So here's a screenshot of Neo4j desktop browser. So when we writing those queries, we put in some parameters first. Then we start writing our Cypher query. We tweak the queries until we get correct result and also acceptable performance. Then we copy and paste those Cypher queries into our schema file, and we have a working backend API. So this is a screenshot of a Postman. You can use other clients which are GraphQL compatible. So you send that query through either front-end JavaScript or Postman. You put in the parameter, you get the correct answer. Data comes back from the API. So basically, that's our backend. With that, let me get back to Todd.
Thanks, Ming. So I'll close up a little with just a few remarks about where Bento is going from here. So the current system is capable of storing data and returning it to users. But one of the things we're finding is that frequently users want to be able to visualize data. So adding data visualization capabilities is one of our next major steps, as well as making sure that the performance stays good. This is, as you might imagine, we want to do this in as modular a fashion as possible so that you can add different data visualization capabilities depending upon what kind of data you are looking at. Now, I'll just close by saying that Ming, Mark, and I are actually just three of a very large team that have been developing Bento. I want to thank everyone who has contributed to this. The listing here from both Frederick National Lab and Essential Software Incorporated. Everyone has been wonderful to work with and has developed a great product. So with that, we'll say thank you. And if you're interested in kicking the tires of Bento, the link here will take you to our quick start guide, which will walk you through the steps.
Great, thank you so much. That was such an interesting presentation. I really appreciate that. We've received some questions from the audience, so I wanted to go into some of the questions, and also remind the audience that if they have questions they'd like to submit, they can do so by typing them into the questions tab located at the top of their screen. And if we don't get to your question, someone from Neo4j will get back to you, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. But as I said, we've gotten a few as we were talking, so let's start with those. So here's a question that was asked a couple different times, and it asks, does Bento have to be deployed in the cloud? Can one of you take that?
Sure. I'll go ahead. No, it does not. Actually, you can set it up on your local machine. You can set it up on a server that you have and control. It works well in the cloud, but it does not need to be deployed there, especially if you have a smaller data set and you have maybe other kind of constraints that prohibit you from putting it out there too far in the internet. So.
Excellent. And this kind of goes along hand in hand is, how long does it take to stand up a test version of Bento?
Yeah, I'll take a crack at that one. Just sort of the default Bento comes with, as Mark said, with a data model that's already built in, and there's a test data set that we provide. If you just go with those, you can set it up on your laptop in as little as a couple of hours if you just want to kick the tires. Obviously, it can take a bit longer if you want to provide your own data model, your own data sets, but we've set it up for rather large data sets within 2 to 4 weeks. So it can go fairly quickly.
Oh, that's great. Thank you. And then here's one. Do you need to use the NCI cloud resources to access your own data?
No, actually you don't. If you have any legitimate Amazon or Google account, you should be able to mix and match data as you see fit. Some of the data we have within the cancer research data ecosystem is controlled access. You have to apply for access, but once you have that, you can mix and match with your own data as you see fit, and your data will remain secure.
Oh, good. Thank you. And let's see, here's another one. Do you have an example of where Bento made a project possible or easier, and how did Neo4j contribute to that?
Todd?
Go ahead. Oh, I was going to say, go ahead if you want.
Yeah, I might jump in from the data side, but if you've got a...
No, go ahead.
So I think that well, one of the key features of Neo4j is its NoSQL ability to accept changes to a model.
Oh, I think we've lost your sound there, Mark. And Todd, do you maybe want to take that one?
Yeah. So I think going along with what Mark said, the ability of Neo4j to easily accept data model changes is one of the key features that cause us to actually pick this. And it's something we use on a regular basis, that as new data come in, there need to be changes to the data model, both on ICDC and on the clinical trials data commons. And we can have our subject matter experts make those in the text file format that Mark was showing earlier, and easily push those through. So we've really lowered the bar for how flexible the data model is and how easily we can change it.
Oh, that's great. And Mark, do we have you back? Was there something you wanted to add?
I think that covers it.
Oh, good. Well, I think
Thank you very much, Todd.
I think we're actually about time for our session today. So I want to thank you, Ming, Todd, and Mark, for being with us. We really appreciate your time and sharing your use case and what you're doing with us. That was great. And for
Thank you very
those-
much.
For having us.
Thank you for having us.
Oh, absolutely. And for those of you in our audience, thank you for joining us today. And I wanted to let you know that our next connections featuring knowledge graphs will be held at the end of July. And that in the meantime, we'll be hosting our Nodes Summit at Neo4j Online Developer Expo and Summit taking place on June 17th. So you can find more information about that on our website, neo4j.com/nodes. You can go ahead and save your spot for that. And with that, I want to thank you all again and have a great day.
Thank you.
Thank you.